Good afternoon, weather and climate class. So this is our first video lesson for the early chapters. So we're in chapter 1. Chapter 1 is pretty straightforward, so this will not be a long video lesson, just a handful of notes on the board that we're going to discuss, and then I'm going to move over to the PowerPoint and film a handful of slides to discuss them. So I think that, and I think that'll do it for chapter 1. And the things that are on the board are in the PowerPoint, but if it's something extra important, then I will take time to make a video lesson of it. That being said, I'd like you to read the entire PowerPoint when you have time with the class notes. And again, I'm still working on narrating those. So, question. How did our atmosphere originate? And the answer is volcanic outgassing early in Earth's history gave us the atmosphere we have now. It has not always been as it is now, and if you take the Earth history class in the spring, you'll learn a little bit more about that. All right, next question. Where did our molecular oxygen, as in O2, come from? And I'm sure you already know the answer to this. Photosynthesis. So photosynthetic plants have given us the current amount of oxygen level that we have. Speaking of, our next topic, what are the fixed gases in our atmosphere? I have fixed in parentheses because they're relatively fixed, or in the short run. They have varied over the course of Earth's history, and carbon dioxide is actually varying in our very recent history. So let's go through these. So N2, also known as atmospheric nitrogen, makes up most of the air we breathe, 78%. O2, atmospheric oxygen, makes up 21%. Less than 1% is argon and a mixture of every other gas that's out there. And then carbon dioxide. When I first started teaching here at UNC Pembroke 12 short years ago, carbon dioxide levels were 0.037. Okay, so in a very short time frame, they have risen 0.039 very recently. Now they're saying 0.04%. This may be different than what you see on the PowerPoint, because you know what, guys, most slides in this PowerPoint are kind of old. I kind of like leaving them in there though, so we can discuss these changes. Carbon dioxide levels are increasing, and we are able to measure that in real time. We're going to move over to another part of the board. To move a chair, means I'll have to move it back Monday, so nobody sits where they shouldn't. Okay, we are going to take a look at the variable components of the atmosphere, meaning what kind of things are in the atmosphere that are not fixed. So we have ozone, which is known as O3. So notice that ozone is different from atmospheric oxygen. It's O3 instead of O2. Ozone. We'll learn more about ozone in later chapters. You've probably heard of the ozone layer, which is very important and necessary for life on this planet as we know it. And it hangs out in the stratosphere, and the ozone layer is a good thing for us. It protects us. Oh, by the way, make sure when you are reading through all the PowerPoint slides for chapter 1, don't forget to take a look at the images, computer model images of the hole in the ozone layer. It is getting better. And I'm sure we'll see this in a later chapter. Back around, I think around 1980, they discovered a hole in the ozone layer, maybe late 70s, maybe it was around 1980, they discovered what was causing it. CFCs, chlorofluorocarbons, that we were using in refrigerant and propellants and just various industrial activities. So a lot of nations got together and signed the Montreal Protocol saying that we would phase out the use of CFCs. So we have, and the hole in the ozone layer appears to be slowly repairing itself, not quite as big as it used to be. It hangs out over Antarctica. That's a great place for it to hang out. There are no permanent human residents in Antarctica. We still need to fix that hole in the ozone layer though. And then we'll learn a little bit more about tropospheric ozone in a later chapter as well. Actually, I take it back. It's in chapter 1. I'm just not going to do a video lesson on it. So Ozone, O3, can be created down here in the troposphere where we live and breathe by industrial activities, and that is not a good thing, and it is bad for people with asthma or COPD. It's bad for plants, animals, insects. It causes rubber bands to deteriorate and break, all kinds of stuff. All right, moving on past ozone. Methane, I'm going to go ahead and include methane as a variable component of the atmosphere because methane levels are increasing as well. Methane the levels are pretty small, but what's scary about methane is that it is a greenhouse gas, and it is a powerful greenhouse gas. It is anywhere from 6 to 24 times more powerful a greenhouse gas than carbon dioxide. And methane levels, they are increasing, lots of reasons, like melting of permafrost. Gonna have to keep an eye on that. Aerosols, which are tiny solid and liquid particles. I have some examples of the solid aerosols up there. That's not an exhaustive list. There are other examples. These are the ones I can always come up with off the top of my head. Dust, pollen, sea salt, silt, clay, and volcanic ash. Aerosols, by the way, the solid ones, make good condensation nuclei for rain droplets. Volcanic ash, if you have a large enough volcanic eruption that ash goes above 7 miles, so above the troposphere, it hangs out in the stratosphere, it's above the weather, so it's not raining back down to Earth quickly. And in the short run, over the course of a few months, it can actually block some incoming solar radiation and temporarily cool planet Earth. By the way, we will learn all about heating of the atmosphere in chapter 2, so we're not going to get into heating of the atmosphere in this chapter. What is another variable component of the atmosphere? Water vapor, which is the most important variable component of air. Why is that? Several things. It is the source of all clouds and precipitation. Water vapor, we need it. We do. We don't need too much of it. Hey, just so you know, every 1 degree Celsius warming of sea surface temperatures leads to at least 6% more evaporation of ocean water. Yes, we have more water vapor in the air than we had many decades ago, available to rain down on us in various rainfall events, thunderstorms, and of course tropical systems. Why else is water vapor such an important variable component? It is a greenhouse gas, and that means that it absorbs and retains Earth's heat. We will learn more about terrestrial re-radiation in chapter 2. What else about water vapor? It absorbs and releases heat energy. Okay, so let's do evaporation first. Evaporation absorbs heat. This is why humans have evolved sweat glands. Why do we sweat? To cool down our core body temperature. So when we sweat, there's water on our skin, and what it takes to cool us is evaporation of that water into the atmosphere around us, and that has a cooling effect on our bodies. That's why we sweat. Now, condensation, as in water vapor turning into droplets, that releases heat energy. That's going to be important in later chapters when we talk about, say for example, building up cumulonimbus clouds, big thunderheads that go up into the, overshoot into the stratosphere and bring us some violent weather. So the more condensation you have, the more droplets you form, you're releasing energy, you're heating that air mass even more. It can rise to ever higher heights in the troposphere and condense more, release more heat, and build one of those afternoon, evening thunderstorms in the summer. Okay, I'm gonna shut off the camera and change the lights and the iris on the camera and get some PowerPoint slides ready. So we'll have 2 short videos for chapter 1. Be back in a minute.